I didn't mean to end the recording there because I need to read all the answers. Oh shit, I just realized that I can do this. And maximize, or I can bring it back to what it was. Like that. I had no idea. Excuse me. Functions are not typically referred to as compound types, but rather as compound data types, but rather as function types. Okay. Compound data types usually mean, I mean, that makes more sense. It was saying that functions are one, but not typically. Function type example is confusing. Functions are not compound data types in the same sense. It makes sense. Compound data types are constructed from fundamental types, like these guys. Yeah, as if I know what a struct is yet, buddy. Contains two integers. Okay. Could be more explicit. If a const expression function is evaluated at compile time, all functions it calls must also be const expression. Otherwise, it can call non-const expression functions at runtime. Gotcha. Could add that const eval functions cannot be called at runtime at all. Well, I thought that I said that, but I guess not. Alright, I'll take that. Const eval requires arguments to be const expressions. Yes, okay. The restrictions of a const expression function must only contain a single return statement. Well, isn't that all functions? Must not have side effects. Really? I don't know if that's true though, because I think I had a const expression function earlier. Oh, or maybe it's when it's at runtime that it doesn't have a side effect, or that it can have a side effect. Oh, and all code paths must be not necessarily true. Not all code paths. At least one must be valid at compile time. For declarations for templates are rarely useful because the definition is needed in every translation unit. Well, yeah, I agree, but maybe you want it at the bottom, so it depends, I think. Function parameters cannot be const expression. Rather, function parameters cannot be used as template arguments. Hold on. Function, well, not template, not, yeah, but function parameters cannot be used as template arguments because they're not const expression. I disagree with this. Okay. The compiler generates the instantiation automatically when you call the function with specific types. True. I guess I can say automatic though, that we don't have to do it. Could be more concise. Provide a default argument by assigning a value in the function declaration. All parameters of default arguments must come after those without. Okay. If you define a body for a deleted function, the compiler will error because a deleted function cannot have a body. Okay. Basically, just don't just delete the body if you deleted the function. Okay. Well, yeah, you wouldn't. Well, the point is if we have a function definition and we delete it, you have to remove the body. Otherwise, you get a second error. A concrete error of overloads? I thought I did. None. None. Trailing return type for auto? Oh yeah, true. So we could say auto something and then the little pointer thing at the end for like long types. Auto deduces the type from the initializer. I did say that. None. None. Arithmetic conversions are definitely, yeah, I did mention the usual arithmetic conversion rules, but I'll say that they're explicitly governed by the usual arithmetic conversion rules. Usual arithmetic conversion rules. List initialization prevents them. That's exactly what I said, but I could say that it prevents it. Okay. Possible data loss of numeric conversions. Oh, if we're talking about implicit conversions, well, there might be data loss. I don't know the difference between truncation and, it seems like truncation is what happens in an error conversion. Okay. Be more concise when saying floating point versus integral promotion. I mean, I was just giving a bunch of examples, bitch ass. Assert can be disabled. Oh yeah, by including or by defining NDebug in the as a preprocessor directive. Standard character input clear and ignore. Oh well, it's true, but you only said how to check if it's failed. You didn't say the other stuff. But yes, we can use standard character input clear to remove the failure flag from standard character input from the input buffer. If the input buffer is detached, we're fucked. Or disconnected, we're fucked. We have to abort. and we can detect that by doing standard character input.uf. We can do ignore and then pass it the maximum amount of information that can be stored in an input buffer, and then pass it, and then comma space an inline character to ignore everything in an input buffer. So everything else until we get to that, or just everything. If you can somehow submit information input without an input buffer or without an inline character, but I don't think you can. Improvements more specific about error handling mechanisms, exceptions, and return codes. I don't know much about exceptions. We can return with specific codes, so sure, we can say like, hey, we can have a namespace with the error codes, and we can say, hey, we can have an error code, and if we apply damage to a character and it uses negative damage, then we can abort. Well, I'd rather just use an assert, to be honest, instead of just doing standard exit with a specific code. I mean, we could do standard exit needs a code. I'd honestly rather just abort. But I mean, sure, you could have functions that return specific things. So like instead of just doing void apply damage to something, we could do int apply damage, and then it returns 1 if the damage was negative or whatever. But I'd rather just use an assert and make sure the damage isn't negative and handle it instead of doing return codes. Return codes kind of feel like doing standard character output in here, like doing debug prints, which are worse than just having an error that triggers when it happens, because you can lose the prints in the dialogue. I'd rather have an error box. Improvements, and in an assert too, I can do and the logical and operator to append a message to the error. That way we know what the error is saying, instead of being like, oh, it returned with code 5, that's okay, and then I have to go and look and see what the code 5 is. Feels like annoying. It feels like bullshit. High coverage doesn't guarantee bug-free code. Yeah, makes sense, because we haven't tested all the cases. Sure, we've tested each line of code, but we haven't tested it with all values. We need to do the same test with different values for each line or each type of input. So like, oh, try negative input, try positive input, try big input, try small input, try input in the middle, try whatever, something else. Could mention that testing improves code reliability and maintainability. Well, yeah, if we test it, it makes it more robust, and if it's more robust, then it's probably at least more reliable and maybe more maintainable too. Could mention the risk of global state. Oh, if we have random H, the risk of global state. Yeah, I don't know anything about thread safety. More concise. None. Cool. Well, I mistyped one time. Fuck off. Definitions aim for precision and completeness, but avoid unnecessary verbosity. Provide concrete code examples. Okay, cool. Sounds good to me. All right, thanks. All right. That's 6 hours of studying today. 6 hours more tomorrow.